Okay, we are in Unit 1, Lesson 5. This lesson comes from Chapter 4, Section 5 in the textbook. This lesson is about completing the square, which is another method for solving quadratic equations. Our content standards for this lesson are that we're going to look at how to solve quadratic equations with real coefficients that have complex solutions. And we're going to use the process of factoring and completing the square in a quadratic function to show zeros, extreme values, which are maximum and minimum values, and symmetry of the graph, and then interpret these values in terms of a context. Our mathematical practice for this lesson is we're going to look for and make use of structure. So, in the past, in previous lessons, we've already factored perfect square trinomials. If you don't remember how to do that, there's a poster in the classroom that shows the formula for perfect square trinomials. In this lesson, we are going to solve quadratic equations by using the square root property and solve quadratic equations by completing the square. Here's some new vocabulary. Oh, just completing the square, only one word this time. Okay, our first example is going to be on an equation with rational roots. Rational just means that the answers can be expressed as fractions or ratios. Ratios and fractions are the same kind of concept. So our problem says we need to solve x squared plus 14x plus 49 equals 64 by using the square root property. So hopefully from previous lessons you are able to factor this or recognize that this is a perfect square trinomial of the form quantity a plus b squared, where a is x and b is 7. You would recognize that by noticing that x squared is a perfect square, it's x times x, and 49 is a perfect square, it's 7 times 7, and that 14x is 2 times x times 7. 2 times 7 is 14, obviously. So this you can rewrite as a perfect square trinomial. Then we're going to take the square root of each side, so the square root with this thing will cancel out the square. The square root of 64 is plus or minus 8. Then we're going to subtract 7 from each side. So we have negative 7 plus or minus 8. And on the next screen, we're going to look at how to solve each of those equations. Negative 7 plus or minus 8 means you have one equation with negative 7 plus 8, which answers is 1. And then the other equation will be negative 7 minus 8, and the answer to that is negative 15. So our two solutions are x equals 1 and x equals negative 15. You can always check your work by plugging your answers back in. If you do that, you'll see that both of these equations come out to show that each side is 64, thus proving that both of these answers are correct answers to the equation. Here's one for you guys to check your progress on. You need to solve x squared minus 16x plus 64 equals 25. Pause the video, come back when you have your answer, and advance to the next slide. And our answer here is C. The answers are x equals 3 and x equals 13. Okay, in example 2, we're going to be looking at an equation that has irrational roots, which means that they cannot be expressed as a fraction. We need to solve x squared minus 4x plus 4 equals 13 by using the square root property. So again, this problem on the left side of the equation is a perfect square trinomial. This is x times x. This is negative 2 times negative 2. This is negative 2ab. So this left side factors into x minus 2 quantity squared. Then we're going to take the square root of each side. So we have x minus 2 is plus or minus the square root of 13. Here, notice the square root of 13 can't be simplified. So we bring the 2 over to the other side. We have 2 plus or minus the square root of 13. I would actually prefer if you left your answers right here as 2 plus or minus the square root of 13. But if you ever come across a problem that asks you to give exact answers to like 1 decimal place or to 2 decimal places or something like that, then you need to go ahead and type this in your calculator as two different things, 2 plus the square root of 13 and 2 minus the square root of 13, and then give me the decimal approximations. But only do that if the problem specifically says that to do that. Otherwise, if it doesn't specifically say how to keep your answer, I would prefer if you leave it as 2 plus or minus the square root of 13. And again, you can always plug your answers back in and just check to make sure that the two sides come out to be equal. Notice what they did on this previous slide is they pulled everything over to the left side of the equation, move this 13 over, so you get this equation x squared minus 4x minus 9. And then on this next slide, they're going to throw that equation in the calculator and use the 0 function that we showed in class. And notice this first 0 is at the negative 6.1, which we found already. And then over here, if you do the same function again, you'll get 5.61 over on this side. Okay, here's one for you to check your progress on. Pause the video and work on the answer. And when you have your answer, come back and advance to the next slide. And our answer here is 2 plus or minus 2 times the square root of 2. Okay, the key concept for this lesson is on the concept of completing the square. And it says basically what we need to do is to complete the square for any quadratic expression of the form x squared plus bx. The first thing you're going to do is find half of b. Then you're going to square that answer. And then you're going to add your answer to the end of this. And when you add that, that's kind of like the c value over here. So notice how they added it onto the end. So basically what you need to remember is that this last piece is b over 2 squared. And when you factor something like this as a perfect square trinomial, it factors into x plus b over 2 quantity squared. All right, for example 3, we're going to be practicing completing the square. We need to find the value of c that makes x squared plus 12x plus c a perfect square. And then we're going to write the trinomial as a perfect square. So again, the first thing we want to do, our b value is 12, so we want to find half of 12, which is 6, and then square it. 6 squared is 36. So we're going to add that to x squared plus 12x over here, adding it onto the end. So that means our c value is 36 for this problem. And when we factor that, remember it's x plus b over 2 quantity squared, and b over 2 is 6, so it factors as x plus 6 quantity squared. Thanks, Cormax, for interrupting my video again. Okay, here's an example for you to check your progress. Find the value of c that makes x squared plus 6x plus c a perfect square, and then write the trinomial as a perfect square. Pause the video as long as you need, and then come back when you have your answer. And our answer here, c is 9, and it factors into x plus 3 quantity squared. All right, example 4, we're going to solve an equation by completing the square, and our equation is x squared plus 4x minus 12 equals 0. When you have this kind of problem, you should notice first off that the way it's written is not a perfect square, because 12 is not, it's not like 2 times 2, it's not 3 times 3, it's not 4 times 4, it's not a perfect square. So when that happens, what you need to do is bring this c value that's in the problem already over to the other side. And notice it changes sign when you bring it over. Then look at the b value. B is 4, so we're going to do b over 2 and square it. B over 2, 4 over 2 is 2, 2 squared is 4. So we're going to add 4 to the left side like we did in example 3. But now, because it's an equation, we have to also add it to the right side. Whatever you do to one side, you have to do to the other side. You simplify the right side, 12 plus 4 is 16. And we simplify the left side by factoring and writing it as a perfect square. Remember that it's going to be x plus b over 2. b over 2 was 4 divided by 2, which is 2. So it's x plus 2 quantity squared equals 16. They kind of jumped ahead a step here, but remember, let me pull this back up. What we're going to do here now to solve it is we need to take the square root of each side. So we're going to square root the left side, we're going to square root the right side. When we square root the left side, it's going to cancel out this square. And when we square root 16, we get plus or minus 4. So we subtract 2 from each side, negative 2 plus or minus 4. First equation is negative 2 plus 4. Second one is negative 2 minus 4. You simplify each of those, and you get 2 and negative 6 as your two answers. Okay, here's a problem for you to check your progress. You need to solve x squared plus 6x plus 8 equals 0. Pause the video as long as you need to work on this, and then come back when you have your answer. And our answer here is B. The two x values are negative 4 and negative 2. Okay, here's an equation where we have to complete the square, but where a is not 1. Notice, if you didn't notice yet, and all the other examples of this lesson, this a value over here was 1, but now it's not going to be 1. So first, we need to realize this is not a perfect square. You can't multiply any number by itself and get 3. Over here, you could do 1 times 1 and get 1, but the 3x squared is not a perfect square. So the first thing we need to do is divide every term by the a value of 3. So when we divide the first term by 3, the 3's cancel. When we divide the second term by 3, we get negative 2 over 3. Divide the third term by 3, we get negative 1 over 3. And we divide 0 by 3, and it's still 0. Then you're going to bring the negative 1/3 to the other side. It becomes positive 1/3. And then this is the tricky part. I know you guys hate fractions, but we're going to take half of negative 2/3. When you take half of negative 2/3, it's the same as multiplying by a half. Negative 2 over 3 times a half. These 2's cancel. That would be negative 1 over 3 squared. Negative 1 squared is positive 1. It's negative 1 times negative 1. 3 squared is 3 times 3 is 9. So our b over 2 value squared is 1/9. So we have to add 1/9 to each side of the equation. Remember, our b over 2 was negative 1/3. So this left side of the equation simplifies to x minus 1/3 squared. And the right side, let me pull back on the previous page. When we add 1/3 plus 1/9, you need to get a common denominator. Our common denominator is going to be 9. So to make this 3 into a 9, we'd multiply by 3 on the top and the bottom. So this would be 3/9 plus 1/9. 3/9 plus 1/9 is 4/9. So on the next page, that's why the 4 over 9 is here. We're going to square root each side. So on the left side, the square just goes away. On the right side, the square root of 4 is 2, and the square root of 9 is 3. So we have plus or minus 2/3. Then you're going to add 1/3 to each side. 1/3 plus or minus 2/3. And then simplify that. 1/3 plus 2/3 is 1. 1/3 minus 2/3 is negative 1/3. So our two answers are x equals 1 and x equals negative 1/3. All right, here's a problem for you to check on your own. You need to complete the square. Remember, first thing you're going to have to do is divide everything by 2. Pause the video as long as you need, and then come back when you have your answer. And our answer to this problem is A. The x values are negative 3 and negative 5 over 2. That's going to be the end of this video.